Hi, in this video we're gonna continue to explore Temp Table, and through this video I wanna talking about approximate compressed liquid using saturated liquid. So this is a new topic, and in order to do that we're just gonna focus on this particular problem. This is from WebWorks. Okay. So for this one, they're giving us the two properties. The first one, temperature, 60 degree, and the pressure is 109.7 kilopascal. So here, we do not know what phase this is. So we have to determine that first. And you have both temperature and pressure. You can do either way. You can use temperature table A4 or using pressure table A5. I normally like to use pressure table, but here I will do both. Then you will see why pressure table is preferred by me. So let's see if we go with the pressure table. So if we go with table A5. So if we go ahead to method 1 using the pressure table, and 109.7 Pascal. Okay, so let's go to A5, 109.7 Pascal. So it's about 111, and well, obviously in this pressure table there's no 109 or 110, and so it's between this 101 and 121, right? And then note, it's okay, we don't have exact pressure, and that happens quite often, so embrace it. And then here is the saturated temperature for atmosphere pressure 101. This is 99.9, so it's 100. This is 105. So you know if it's 109 kilopascal, you can estimate it's going to be between 100 and 105. If you want to know the exact value, you can use linear interpolation to do it, but really no need for this step because I just know it's 100 to 105. And why? Because my temperature here is only 60 degrees Celsius. It's going to be way below 100 degrees Celsius, right? So, and your number is going to be between 100 and 105. So you know this, without finding the exact value, I know this T 60 degrees Celsius is going to be way less than this saturated temperature at this 109.7 kilopascal, because you know this is in a range of 100 and 105.97. So it's in that range. So our 60 degrees Celsius is going to be less. So that's all right. And knowing that, we know this is going to be compressed liquid, right? If it's less than Tsat, that's going to be compressed liquid. Okay. All right. Then we're going to look at method number 2. So we determine it's compressed liquid. Here I'm going to demonstrate using the temperature table, table A4. Okay. Using the temperature A4, we should get the same value, same answer, compressed liquid. But here is how. If we've given 60 degrees Celsius now, so let's go to table A4. And we're looking at the 60 degrees Celsius. And what's our saturated pressure at 60? It's 19.947. So it's about 20, right? So I round up. So it's about 20 kilopascal. So this is our Psat at this 60 degrees Celsius. We said is 19.947. So let's write it down. Kilopascal. And our given pressure is 109.7 kilopascal. Then how do we know this is compressed liquid? we really didn't talk too much about those in this, but here we go. We can look at this PV diagram. We talk about using TV diagram a lot, but let's use PV diagram. We know with PV diagram, this trend is going downward, right? There's a one lecture on that, because when you increase up the pressure going this way, your specific volume should decrease as well. So this is gonna be your constant temperature line. Now remember, this is region 1, region 2, region 3. 1 being compressed liquid, 2 being saturated liquid vapor mixture, 3 being the superheated vapor. And what do we got here? Our pressure here, given pressure, is 1 line. This is our PSAT at this temperature, let's say 60 degrees Celsius. Our PSAT is 19.947. However, our given temperature is what? 109, way above. It's not going to be 3, because 3 is going to be low. This pressure is going to be below this one. It's not going to be 2, because it's going to be equal. Only it's going to be here. So that what region is this? Region 1, which is compressed liquid. Okay? So you can go ahead reason it out too. And that's why I always like to use pressure table. Why? Because pressure table for me personally is intuitive. From pressure table, I find a boiling temperature, the TSAT, and I use the given temperature to compare with that. If it's less than that, I know it's going to be compressed liquid. That's intuitive to me. Okay? So either one you can do, but if you're going to use the temperature table right here, you're just going to thinking about this PV diagram is going this direction. So either one will be fine. So if it's compressed liquid now, how we are going to find out, we need to find out volume and X. Well, X is meaningless, right? It's not available because it's compressed liquid. X quality only apply for mixture. And how about specific volume? Now let's go into compressed liquid now. Which table is compressed liquid? That's right, table A7. And remember, this is what we have. So far, we just figured the phase based on temperature and the pressure, this combo. And now let's go using this combo to the right table to see if we can find a specific volume. So table A7. Okay, we're at table A7. Not yet, getting there. Again, it's mainly table. And remember one time I mentioned about in the steam table basics, I said the minimum pressure in the compressed liquid is 5 megapascal. And our here pressure is what? 109.7 kilopascal, which is 0.1 megapascal. It's way less than this 5 megapascal. That's in table A7. So we're stuck. In other words, A7 cannot give us answer. Because the minimum pressure they have there is 5 megapascal. Ours is 0.1 megapascal. Then what do? So we're going to approximate. Since this is compressed liquid, we're going to use saturated liquid to approximate, to estimate it. So here's how. This V we're solving is going to be approximate as VF because it's a liquid, right? So we're going to use saturated liquid, VF, specific volume for saturated liquid. And however, we have both temperature and pressure. Which one do we use? We absolutely have to use this temperature. That's the key. I'm going to highlight this. This is important. Why? You think about it. If it's liquid, liquid is what? Non-compressible. Yeah, in other words, if you put pressure on there, the volume of the liquid doesn't really change. However, air is compressible. You put pressure on there, it's gonna be compressed. Liquid is considered as non-compressible. In other words, pressure doesn't do anything to it. You know, pressure does not affect it. However, which one affect? Temperature, however, does. In other words, we're going to use temperature to approximate. To put into this problem, so we're going to approximate. So that's the topic here we're getting into. We're going to use saturated temperature. We're going to use the saturated liquid to approximate. Approximate using saturated liquid at the temperature. So for this, we're going to use VF at 60 degrees Celsius. So what table then? That tells us is going to be table A4, a temperature table. So now, since A7 cannot give us answer, we're going to go to table A4. So let's go to table A4. Go back to table A4. And we're going to look at 60 degrees Celsius. We are here. And we are solving for V. And we said we are going to use saturated liquid to approximate. So it's VF. That's our answer. 0.001017 meter cube per kilogram. That is our answer for this problem for specific volume. Here, I'm going to extrapolate just a bit. Only one last thing is, if this problem they also ask you H, what's the enthalpy, what's the S, etc., what's the internal energy, here it goes the same concept. You're going to use specific enthalpy at this saturated liquid at 60 degrees Celsius to approximate. This S going to be the SF at 60, and U, internal energy, will be the same. Okay, for that situation, I'm going to get those answers from the table to finish this problem. Then for our U, it's going to be 251.16. That's our UF table. Our S, and this is going to be in kilojoule per kilogram. Our H is going to be this one, HF, 251.18. And our S is going to be SF, which is 0.8313 kilojoule per kilogram per Kelvin. That's all for this problem. All right, so that concludes when you identify a compressed liquid and you want to use saturated liquid to approximate if the pressure given is less than 5 megapascal. And include this video, you also learned when the temperature and pressure are both given, you can use either of them, A4 or A5 table, but intuitively, I like to use pressure table for everything. Then I compare what's given, the temperature, to the saturated temperature. If it's less, compressed liquid. If it's the same, if it's a saturated liquid vapor mixture. If it's higher than this boiling temperature, we know it's going to be superheated vapor. All right, so that's end of this video. See you next time. Bye.